Hey folks, so today we'll talk about the personal knowledge graph and the modeling of the things. As you know, the personal knowledge graphs is not just about the graphs. So it's not a pure mathematical theory. Yeah, for sure, it's a directed graph, but we encode some semantic knowledge to it. And all these personal knowledge graphs and knowledge graphs are started as a part of the concept of the linked data and semantic web. So we get this concept actually from the web, and this is a simple concept that we have the data that form the islands that connect with each other. That's why we have a lot of standards around the linked data, connected data, and all those things. And for sure, if you will talk about the modeling of the personal knowledge graphs, the biggest part and actually the huge industry standard is the resource definition framework. And in a resource definition framework, actually you have the ID that probably should be the URI or the UUID, right? So for the local data. And around this ID, actually, you attach different things with the help of the triples. We could encode in this way the connection between three resources and form the classical triple of the one node that connected to another via some link. We could connect the properties to the entities or the edges. We could actually connect some or encode some hierarchical data. And over the years, the RDF together with the RDF schema evolve for sure. So in some point we get some complex objects like sets and lists, and for sure the biggest one, it's nested graphs that allow us to create a named graph that allow us to create actually the nested graphs and all other things. So even in RDF space, you have a lot of tools that allows you to demodel reality in quite different ways. But in the same time, it's create a lot of constraints because you're really dependent on the storage and the triple store and all of the things and how you actually encode these triples. And I have a separate article that describe why the triples are not enough, especially when we're talking about the time and temporal context and all those things. But we will not go this way. But right now you have the multiple tools. Yeah, you have the classical triple, you have the ability to connect the properties, you have ability to connect the labels and all of the things. But you get it with the cost, because this triple is quite basic, and to describe some complex models like the entities, for example, that store it inside the node, you will have quite robust, rich graph with the big amount of edges and connections, and maybe it's quite hard to work with such things. That's why in the same time with the RDF and the triples, we get the property graphs. And property graphs actually have a bit slightly different concept. Because together with the structure of nodes and edges, and they actually have the distinction between the nodes and edges, because in RDF you just have the resource, and this resource potentially could change the role. But in a property graph we don't have this flexibility. We have the node, we have the edge, and together in a node we have the ability to have the attributes. And actually the property graphs is how, for example, the Neo4j, the biggest and the most popular graph database, actually works. And this model much simpler. Actually, it's not simpler, it's different, but it's closer to the engineer's mindset, that you have the entity have a property, this entity connected with another entity, and as a side effect, it's condensed the graph. So your graph gets much smaller, and the properties live inside the nodes. They have defined structure, they have defined shape, and as a result, you get less connections. But in a property graph, you lose the ability to actually connect the different properties and create the relation between the properties. And actually it could be quite important feature. Yeah, so that you could connect the different properties inside the entity and give the extra explanation to it. And yeah, so the property graphs, it's most popular thing ever. So you have the Neo4j, you have the Neptune, you have a lot of databases that actually have this model. And for sure, right now we have the GraphQL and all other standards that actually emerge on top of the property graphs. And if in RDF you have the SparkQL that more oriented to the linked data, so in the property graph you have the GraphQL that really in a quite visual form operates with the nodes, ages, and attributes as a three big concepts. And even in a property graph, we have ability to put something to the attributes, or maybe model something as a sub-entity, or maybe create extra ages and all of the things. So that it's still quite rich, and it really depends on what you want to model, even if it's not so flexible as the RDF. And I propose yet another third approach, actually, that still could be fitted to the RDF with the subgraphs, but give us a bit more flexibility of describing the complex entity. That you could model your properties of the entity as a subgraph. So you could model it as a named graph. Yeah, so you have the graph inside the node and then create some connections. And it's really give you the flexibility and the complex objects, and you getting back the ability to connect the different properties with each other. But in the same time, you have a challenge that you will be not able to model it in a classical property graph databases, but you still could model it as RDF triples. So you have the flexibility, but you always have a choice that, how to model the things. Do you want to move it to the attributes? Do you want to move it to the subgraph? Or do you want to encode it somehow as a nodes? And it will create completely different topology, and this topology will really dictate you how you will query it. And you need to know that Neo4j is quite sensitive to query on the attributes, because they encode the attributes as linked lists, and it's a huge space that sometimes are quite hard to query. When we're talking about the classical databases, I have a lot of articles that describe how we could encode completely different things as a graph in a relational model. You have possibility to model some indexes and make it more effective. And for sure, the last piece that maybe the directed graph are too constrained, and you always could go to the space of the hypergraphs, the edges that could hold the multiple nodes and all those things. And you could watch my video about the hypergraphs and metagraphs and how to use the metagraph for the artificial intelligence for sure. But we have a lot of modeling possibilities, but we always have a challenge to decide what we want to do. Do we want to model it as RDF, or do we want to model it as a property graph? And right now you have the third option, that you could model the things not as a property graph, but as a graph of graphs that still keep the rich relations between the properties. So that was all that I was keen to share with you. Stay connected. Choose.